Hi there, welcome to the RPS project. Today I'm going to have a look at the op amp as an actual amplifier. Sounds quite simple, and in this instance it's going to be in relation to DC gain. So DC voltage in, get DC voltage out, hopefully. Now this particular amplifier is known as a non-inverting amplifier, apparently. So sounds quite simple. Put positive voltage in, get more out, hopefully. So let's start with the whiteboard. We'll go a few details and then we'll move on to the breadboard and see the actual circuit in action. Okay, so a quick overview of the LM358. It's 2 op amps. Going to be using this one. So pin 1 is my output, pin 2 is my inverting input, pin 3 is my non-inverting input. Now the supply is plus voltage and I've put ground but also minus voltage because it's an op amp, so really you can use this LM358 designed to work well with a single supply, so connect to ground, but also can be used with a minus. But that's the IC, the LM358. Let's have a look at the actual circuit I'm going to be using. So here we have the actual circuit I'm going to be using. Quite a simple circuit. Op amp in the middle there. Now the input is, as I've said, DC gain, so it's going to be a DC supply, and the way I've done this is used a 10k and a 1k because I want about 1 volts coming in because I'm going to be using a 12 volt supply. So if I'm going to be getting some gain from this, I don't want too high an input voltage because I want it to amplify it and give me a higher voltage on the output. So I've used 10k to 1k, so that gives me about 1 volt just over sort of thing there from my 12 volts. And what I've done is used a fixed resistor and then used a pot so I can move that up and down and change my input from basically 0, so this will be tied to ground, to some voltage around about that I'm going to get in. So it'll give me an output. Now the output and the gain is determined by these 2 resistors. Now there is an equation, I'll go over that in just a moment. It's quite simple, but what I've done is I've actually measured the resistance of these 2 resistors specifically so that I can supposedly be quite accurate about the output that I'm expecting to get from this amplifier. So I've got a 5K55 and 998R. Now let me just write on this, so that's R1 and R2. Yeah, that's the right way around. So R1, R2, they're my values, so that's what I'm going to get. So let's have a quick look at the equation and see what I'm hoping to get out from this amplifier. So here we have the equation. Hopefully everybody can see this. 2 resistors, R1 998 and R2 5K55. So the equation for the gain, voltage amplitude, I think that means the gain, is R2 divided by R1 plus 1. Sounds simple enough. So that would be 5,550 ohms divided by 98 equals 5.56 plus 1. So my output, my gain, should be 6.56 volts, or thereabouts, I presume. I mean, there's going to be factors like spaghetti junction, because I've always got wires all over my breadboard, losses, it might not be proper 12 volt supply, you know, there's all lots of other factors, but I think I've got a relatively good idea of what I'm expecting to see out from this amplifier. So let's have a look at it in action. Okay, so here we have the circuit on the breadboard. Nice, simple. 4 resistors and an op amp. What more do you need? These are just to help with the supply voltage. This multimeter is going to be showing the voltage input, and this one's going to be showing the voltage output. So when this goes up a little bit, that should go up quite a bit. So if I can do this without getting my hand in the way, let's see if this works. Oh, look at that, already I've got a very small voltage on the input and a much larger one on the output. And as we go up to, look at that, we're almost at 1 volt, and I'm on 160 millivolts on the input. So definitely getting an increased output from this. So if I just keep turning it up until I can't go any further, and we'll see what we're getting against what we're putting in. And that is about it. So actually this was saying that I was going to get, when I calculated it, 6.56. Look at that, that's that dodgy pot. It's not, these pots aren't very good, I have to admit, because they're not designed, they're little trim pots, and they're not really designed for this sort of messing about. They're designed to set your voltage and then be done with. So if I just turn that up again, I've got just over 1 volt going in and 7 volts out. Now I'd calculated 6.56 volts, so it's higher than I was expecting, but yeah, it's I suppose sort of in the ballpark of what I was hoping to get. Like I say, these little trim pots really aren't designed for this sort of turning up and down, because they kills the tracks quite quickly on them. Only got so many operations before they're dead. But anyway, as you could see, I was definitely getting an output that is much higher than the input. And in this particular instance, 1.07 volts gave me pretty much 7 volts output, which is pretty darn good, really. Marvellous. So there you have it. The op amp as an amplifier. Sounds very simple, and it was quite simple, and it was quite easy to set up, really. A little bit of fiddling around, I suppose, to start off with. Put some DC in there and got more out. What more can I say about it than that? I was just wondering, with the op amps though, there are some limitations with using op amps, in that really they're designed for having a supply voltage that's a plus and a minus, so that you can use them effectively, I suppose, with sine waves, with AC signals, but also with the DC signal. I suppose if you get something that's low, you've got that inherent problem that you've got an upper and lower limits within op amps. So in this instance it was easy to do. I was looking at a non-inverting amplifier, putting in a positive DC voltage, getting a positive DC voltage out, so that was quite simple. But if I was working with negative voltages or AC signals, I suppose I'm going to start to run into problems unless I can have a positive and negative supply on that op amp to really make use of its full capabilities. Anyway, that's for another time, but this particular circuit was quite simple, and I enjoyed doing it. And if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.